The directions say to evaluate the limit if it exists. Let's start with example 1. Suppose we have the limit as x goes to 5 of x squared minus 6x plus 5 divided by x minus 5. If I replace x with 5, you notice that we get 0 over 0. Okay, so the question is, what do we do with this? Well, here's how we attack a problem like this. We can write this as the limit as x goes to 5 of. Now, in the numerator, I can factor this into x minus 1 times x minus 5. In the denominator, we can write this as 1 times x minus 5. Now, remember, x is getting closer and closer and closer to 5. X does not equal 5. And so what you do is we can cross off these x minus 5s because x minus 5 over x minus 5 is 1, and anytime you multiply by 1, you don't change the value. Okay? And so this is the limit as x goes to 5 of x minus 1 divided by 1. And by direct substitution, we can replace x with 5 to get 5 minus 1 over 1. And so the answer to this first example is 4. And that's how we do example 1. Let's take a look at example 2. Suppose we had the limit as x goes to negative 3 of. In the numerator, we have x squared plus 3x. In the denominator, we have x squared minus x minus 12. And I claim if you replace x with negative 3, you end up with 0 over 0. And so to handle this question, we're going to write this as the limit as x goes to negative 3 of. Now, factoring the numerator, we get x times x plus 3. Factoring the denominator, we get x minus 4 times x plus 3. But the x plus 3's cancel. And what we're left with is the limit as x goes to negative 3 of x over x minus 4. So if I replace x with negative 3, I get negative 3 over negative 3 minus 4, which is negative 3 divided by negative 7. And a negative divided by negative is a positive. So the answer to example 2 is 3/7. Let's take a look at another one. So in example 3, suppose I had the limit as t approaches negative 3 of. Now on top, we have t squared minus 9. On the bottom, we have 2t squared plus 7t plus 3. And so I can write this as the limit as t goes to negative 3 of. Now in the numerator, we get t plus 3 times t minus 3. In the bottom, we get 2t plus 1 times t plus 3, like so. Now, the t plus 3's cancel, and what we have is the limit as t goes to negative 3 of. Now, we get t minus 3 in the numerator, and we get 2t plus 1 in the denominator. And so this is negative 3 minus 3 divided by 2 times negative 3 plus 1, which is negative 6 over negative 5. So the answer to example 3 is 6/5, because remember, a negative divided by a negative is a positive. So let's take a look at this example. So on example 4, suppose we have the following. Suppose we have the limit as h goes to 0 of. In the numerator, we have negative 5 plus h raised to the second power minus 25 over h. Now, here's what I would do. Now, I want you to notice. We'll put it down here. Isn't a squared minus b squared equal to a plus b times a minus b? And remember, 25 is equal to 5 squared. Okay? So this is the limit as h goes to 0 of. Now, in the numerator, I'm going to factor this as a difference of squares. So essentially my a is negative 5 plus h. And then my b is 5, so I'm going to go negative 5 plus h plus 5 times negative 5 plus h minus 5. And this is all divided by h. And so this is the limit as h goes to 0 of. Notice how negative 5 plus 5 is 0, so I can cross those off. And in the numerator, I get h times h minus 10. In the denominator, I get h, but I can get rid of these h's. And when I do that, I get the limit as h goes to 0 of h minus 10, which is 0 minus 10. And so the answer to example 4 is negative 10. It's a good problem, and it's a really nice way to factor that the numerator. And with that, let's take a look at example 5. Suppose I had the limit as x goes to negative 2 of. In the numerator, we have x plus 2. In the denominator, we have x cubed plus 8. Now, a cubed plus b cubed is a plus b times a squared minus ab plus b squared. And so this is the limit as x goes to negative 2 of. Now, in the numerator, I'm going to write 1 times x plus 2 for emphasis. In the denominator, I'm going to have x plus 2 times. Now, I'm going to square the x to get x squared. I'm going to multiply x and 2 together and change the sign. So minus 2x plus 4. Okay. Now, the x plus 2's can cancel out, right? Because remember, x plus 2 over x plus 2 reduces to 1, just as long as x doesn't equal negative 2. So this is the limit as x goes to negative 2 of 1 over x squared minus 2x plus 4. Okay? And so this is 1 over Now, we get negative 2 to the second minus 2 times negative 2 plus 4. But this is 1 over 4 plus 4 plus 4. And so the answer to example 5 is 1/12. And let's take a look at example 6. Suppose I had the following. Suppose I had the limit as t approaches 1 of t to the 4th minus 1 divided by t cubed minus 1. And so this is the limit as t goes to 1 of. Now, if I factor the denominator, it's a difference of cubes. So I'm going to put t minus 1 times square the t, multiply the t and the 1 together and change the sign, and then square the 1. Okay. In the numerator, we get t squared plus 1 times t squared minus 1. But we're not done yet because t squared minus 1 can break down. So this is the limit as t goes to 1 of. In the numerator, we get t squared plus 1 times t plus 1 times t minus 1. And notice the limit is there. I carry that limit down till I'm ready to apply direct substitution. In the denominator, I get t minus 1 times t squared plus t plus 1. But if you notice, the t minus 1's cancel. And I'll put it over here. What we're left with is the limit as t goes to 1 of. We get t squared plus 1 times t plus 1 on top. And on the bottom, we get t squared plus t plus 1. Replacing t with 1, I get 1 squared plus 1 times 1 plus 1 divided by 1 squared plus 1 plus 1. And so the correct answer to example 6 is 4/3. And that's how we do example 6. So let's take a look at example 7. Suppose I ask you the following. Suppose I had the limit as h goes to 0 of square root of 9 plus h minus 3, all divided by h. And this is a classic one where we have to rationalize the numerator. And so what we're going to do is we're going to multiply the numerator and denominator by the conjugate of the numerator. So, in other words, I'm going to multiply numerator and denominator by the square root of 9 plus h plus 3 divided by the square root of 9 plus h plus 3. And so when we do that, we get the limit as h goes to 0. Now, the denominator looks like h times the square root of 9 plus h plus 3. And in the numerator, we get 9 plus h minus 9. So what I did was I took square root of 9 plus h and multiplied it by square root of 9 plus h, and then I took negative 3 and multiplied it by 3. So 9's cancel, and we get the limit as h goes to 0 of h over h times the square root of 9 plus h plus 3. And if you don't mind, for point of emphasis, I'm going to put h times 1 in the numerator. And the h's go away. And what we're left with is the limit as h goes to 0 of 1 over the square root of 9 plus h plus 3. 1 over the square root of 9 plus 0 plus 3. This is just direct substitution. And so the correct answer here to example 7 is 1/6. Okay. Let's take a look at example 8. Suppose I ask you the following. The limit as x goes to 3 of 1 over x minus 1 over 3 divided by x minus 3. Now, what I'm going to do is the following. This is the limit as x goes to 3 of. Now, the LCD, if I were to simplify the numerator up here, the LCD would be 3x. And so what I'm going to do is multiply the numerator and denominator by 3. And then for the first term. And then in the second term, for the 1/3, I'm going to multiply the numerator and denominator by x. And then we still have x minus 3, if you don't mind, over 1 in the bottom. So this is the limit as x goes to 3 of. We get 3 minus x divided by 3x divided by x minus 3 over 1, right? So this is the limit as x goes to 3 of 3 minus x over 3x times 1 over x minus 3. And so this is the limit as x goes to 3 of. Now, if you don't mind, for this 3 minus x, I'm going to factor out a negative 1. And when I do, I get x minus 3 in parentheses. In the denominator, I get 3x times x minus 3. It's a really, really nice question. And then what happens is these x minus 3's cancel. And what we have is the limit as x goes to 3 of negative 1 over 3x. And by direct substitution, we get negative 1 over 3 times 3. So the answer to example 8 is negative 1 over 9. Now, let's take a look at example 9. So we left off on example 8. So yeah, we're on example 9. Now, suppose I give you this one. If 2x is less than or equal to g of x, which is less than or equal to x to the 4th minus x to the 2nd plus 2 for all x, okay? The question says to evaluate the limit as x goes to 1 of g of x. Okay. Now, let me ask you, what is the limit as x goes to 1 of 2x? Well, by direct substitution, we're going to get 2 times 1, which is equal to 2. And then what is the limit as x goes to 1 of x to the 4th minus x squared plus 2? Well, by direct substitution, that's 1 to the 4th minus 1 squared plus 2, which is equal to 2. And so notice how the limit as x goes to 1 of 2x is the same as the limit as x goes to 1 of x to the 4th minus x squared plus 2. We get the same answer. So by the squeeze theorem, sometimes I've heard of people calling it the sandwich theorem, but I'm going to call it the squeeze theorem here. By the squeeze theorem, the limit as x goes to 1 of g of x is also equal to 2. It has to be. And let's do one more example for this video. We'll call this example 10. Suppose I give you the following. The limit as h goes to 0 of. Now, we get x plus h raised to the 3rd minus x to the 3rd divided by h. Okay. Now, I would recommend doing it this way. This is the limit as h goes to 0 of. I would not cube that out. Okay. I'm going to use this formula that I'm going to write down below. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. We don't have to cube it. So the way I'm going to write this is x plus h minus x times, right? Look at x plus h. I'm going to take x plus h and square it. I'm going to go plus x times x plus h plus x squared. Okay? And I don't even have to square out x plus h. I don't have to distribute. I don't have to do any of that. And then in the denominator, I have an h. So this is the limit as h goes to 0 of. The x's cancel, and we get h times x plus h raised to the 2nd plus x times x plus h plus x squared. On the bottom, we get h. Cancel the h's. And so this is the limit as h goes to 0 of x plus h to the 2nd, and then I'm going to go plus x times x plus h plus x to the 2nd. And then all you have to do is replace h with 0. And you get x squared plus x squared plus x squared. And the answer here is 3x squared. That is a really, really good problem because that's going to lead nicely into the section on derivatives. So, okay, that'll do it for this video. It's on evaluating limits analytically. And we did 10 examples. Thank you.